Good afternoon, everyone. Welcome to English Medium Prep by Exampur YouTube channel. And I'm Kumar Ravi, and I'm your science teacher, and I'm here to discuss some more questions on gravitation. Guys, yesterday we have discussed some previous year's questions based on the gravitation, and today we will also discuss some more questions on the same topic. Okay, so guys, just join this session as soon as possible so that we can start this session. Okay, first of all, I would like to tell you that if you have not subscribed this channel till now, then please do subscribe this channel and press the bell icon button for all notifications, so that whenever we go live, then you can get the notification and you can come live to watch the session. Okay, so as well as you are requested to share this video link among all your friends on through social media, your WhatsApp and your Facebook, or any other social media you are using now and you are connected to your loved ones. Okay, so so that there are many people can be gathered at the same place, and they can also gain the knowledge. Okay, so knowledge has no boundaries. Knowledge can be given to any person residing at any corner of this world. Okay, so guys, again I would like to request to just share this session among all your friends. Exampur is one of the most famous and a very large family of the students and teachers in India, and those who are preparing for the different types of government jobs exams. Okay, and it has been a very popular among the students who have been preparing for the state level and national level government jobs. Okay, now the Exampur family has extended, and now we have started an English medium channel for those who don't understand Hindi and or have some problem in understanding Hindi language. Okay, so now we are in English medium also, so that rest of the Indians can just learn the things and they can do the best in their lives. Okay, so first of all, I would like to tell you that there are many batches running on YouTube which are absolutely free for different types of exams, but few batches are also running those who and they are paid batches. Actually, in paid batches, teachers teach the concepts from basic to high level. Okay, and we also provide the test series or mock test to the students so that they can evaluate themselves that what kind of and how much prepared they are for the exam. Okay, so we also provide such type of mock test, and some after the class session, for the revision purpose, we also provide the study material in soft copy format. It means like PDF format. Okay, so that everyone can revise by those notes or can watch the video. Okay, you can see the videos in paid batches by unlimited times. Okay, and there is a limit of time up to 3 or 4 months or 6 months you can watch these classes, but it depends upon the course that this course has been extended till X months, 4 months, 5 months, like this. Okay, so to join the paid batches, you will have to download our application, our official application. To download our official application, you will have to go to the Play Store, and then you will have to type the Exampur. Okay, and you will have to then search Exampur, then you will find an icon like this and the name of this application, Exampur Sarkari Naukri Prep. Okay, and just install that application into your phone, and after installing you will get the two options: number one, uninstall; number two, open. Then press the open button and then you will find out this kind of window in which two options will be given: login and register. Login and register. Okay, so login and register. After registering you will be a part of our database. Okay, and in this way you can later you can join the paid batch. Okay, like this, because whenever you log in then you will find there are many batches which will be showing at these positions like this. Okay, then you will have to just click on that batch and then you will find out the fees that has to be paid for that batch. Okay, you can pay your fees by credit card, debit card, internet banking, UPI, etc. Okay, so this is the method to just get enrolled into a paid batch. Okay, now we will discuss some questions based on gravitation. Okay, we will discuss some questions based on gravitation. Okay. Now let's discuss. Suppose that, as we have already told you, that the major portion of the questions from gravitation comes from the concept of weight. Okay, and suppose that there is a formula: weight of a body on moon. Weight of a body on moon, this is equal to weight of body on earth. Weight of a body on earth by 6 by 6 by 6 by 6. Weight of a body on earth. Okay, weight of a body on earth. So suppose that there is a question: a body weighs 60 kilogram. A body weighs 60 kilogram on earth when it is carried to moon. How much will it be weigh on moon? Weigh on moon. So a body weighs 60 kg on earth. When it is carried to the moon, how much will it be weigh on moon? जब इसे चंद्रमा पर ले जाया जाता है तो चंद्रमा पर इसे कितना तोला जाता है? तो चंद्रमा पर इसे कितना तोला जाता है ये बताइए। when it is carried on moon, then what is the mass of this body on the moon? Actually, here you see that it has been written like this, and this is a very confusing word, wedge. Actually, weigh is a verb, means to measure the thing by mass, to measure the mass. Okay, so wedge means the first form of verb plus s. Okay, so when we talk about the wedge, it means here we can see the unit of the material. Okay, so this is the unit of the material, and we can see that this is actually mass. This is actually mass, and this is 60 kilograms. Okay, and this is 60 kilograms, because kilogram shows that mass has been measured. Kilogram shows that mass has been measured. Okay, and if the mass has been measured, then obviously we can say that mass have the mass anybody has the same mass anywhere. Okay, if you measure anybody on the surface of earth or in space, you cannot pay anybody in space, but on any other planet. Okay, so the mass of the body will remain same. Okay, so we will say that the mass doesn't changes. Mass does not change, and hence mass will remain same. Mass will remain same. Okay, mass will remain same. So mass will remain same. Please write down. Mass will remain same. Okay, so this is the point. The mass of the body will remain same, and this question was asked in SSC CGL, but many other people got confused actually. Okay, so this is the question. Now we will move to another question, and suppose that if we talk about the gravitational forces, the correct order of strength, correct order of strength. Correct order of strength. Number 1, gravitational force is stronger than electrostatic force is stronger than F nuclear force. B, F electric force is stronger than F gravitational force is greater than F nuclear force. Okay. C, F nuclear forces is stronger than F gravitational is stronger than F electric. D, F nuclear is greater than F gravitational is greater than F electrostatic and gravitational. Okay, so which one is the correct answer? Actually, guys, nuclear force is the strongest force, and then electrostatic, and then gravitational. So D is the correct answer. D is the correct answer. Okay. So D is the correct answer. Because there are some regions that nuclear forces. What are the nuclear forces? Okay. This is a nucleus. Suppose that this is the nucleus of any atom. Okay. Then obviously the attraction force acting between nucleons just means, for example, these are the protons. Suppose that these are protons. Suppose that these are protons, and there is a certain force which holds them, and this is known as nuclear force. We all know that here repulsion force also acts. We all know that here repulsion force also acts. Actually, this is repulsion force. Repulsion force also acts. Repulsion force. Okay. So this is repulsion force. Repulsion force. So when we go for the repulsion force, when we discuss about the repulsion force, then obviously the repulsion force is dominated by the nuclear force, because nuclear force always try to just bind these nucleons. Due to the nuclear force, all the positive charge remain inside the nucleus. Okay, otherwise it would have been a very big blast. Okay, just because of the similar charges placed in at the same plane, same place. Okay, so here we can see that the nuclear forces are greater than repulsion forces. It means they are at electrostatic forces. ठीक है. So this is nuclear forces, and this is greater than F electro. Okay, and this is obviously stronger than gravitational force. Gravitational forces are very weak forces. Okay, gravitational forces are weak forces actually, and hence we can write it as, okay, this is here. So this has been proved. This has been proved. Note it down, please. So नोट कर लीजिए इसको अपने उसमें. Okay. So guys, number 3. Suppose that if we talk about weight on Earth. Weight on Earth is equal to 100 Newton. 100 Newton. Okay. Then weight above H is equal to RE by 2. इतनी ऊंचाई पर वेट क्या हो जाएगा किसी बॉडी का, करके दिखाइए मुझे. चलिए ये करके दिखा दीजिए मुझे, मैं आपको मान जाऊंगा. अब मैंने आपको ये क्वेश्चन करके दिखा चुका हूं पहले भी. नोट कर लीजिए इसको, फराक से मुझे बता दीजिए. Note it down. Okay. Let's see. This is Earth. This is Earth. Actually, I'm not feeling well today. I'm suffering from the cold, cough, and fever. Okay, so this is the radius of Earth, and we have to find out the value of g dash, and g dash will be equal to g upon 1 plus h upon re to the whole square. Okay, and this is the height h, and this is re by 2. This is re by 2. Okay, now the g dash will be equal to 1 plus 1 plus, okay, 1 plus h upon re. H means re by 2 upon re. Okay, so g dash will be equal to g upon 1 plus 1 by 2 का whole square. G dash, this is equal to g upon 3 by 2 का whole square. Then g dash, this will be equal to 4 by 9 g. Okay, 4 by 9 g. Then obviously m into g dash, this will be equal to mg into 4 by 9. Okay, then obviously mg dash, this will be equal to mg. Mg is equal to 100 Newton, or you can write it as 90 Newton. It will be very good because it will divide easily. Okay, 90 Newton multiplied by 4 by 9. Then obviously this 9 will cancel out this by 10 times. Then W will be equal to 10 into 4. 10 into 4. Okay. So here you will find out that 10 into 4, and this will be equal to kitna? This will be equal to itna 40 Newton. 40 Newton. 40 Newton. Okay. 40 Newton. 40 Newton. Okay. So this is the correct option. So this is the correct option. Please write down. So this is the correct option.
Represented.
So this is the final answer. Okay, 40 Newton. Now the question number 3, question number 4. Question number 4. Obviously, question number 4. If a lift is moving with 4 meters per second vertically upward, okay, 4 meters per second square vertically upwards. Okay, calculate the weight of man standing inside is standing inside is standing inside standing inside is standing weight of man is standing inside having mass having mass having mass 100 kg. Okay, g is equal to 10 meters per second square. G is equal to 10 meters per second square. G is equal to 10 meters per second square. G is equal to 10 meters per second square. So this is a lift. Okay, this is a lift and the mass of this man is 100 kg. Okay, lift is going with acceleration 4 meters per second square. G is equal to 10. Okay, G is equal to 10 meters per second square. Okay, then calculate the weight of man. तो obvious सी बात है, obviously इसका हमें weight find out करना है. Then the apparent weight apparent weight of the body. Okay, we have to find out the apparent weight. We have to find out the apparent weight. Okay, apparent weight. So apparent weight W dash. So W dash, this is equal to M into G dash. Okay, and this G dash this is equals to this W dash, this is equal to M into G dash, and this is M into G plus A. Actually, when the lift goes vertically upward with some acceleration, then the apparent weight of the man becomes M into G plus A. Okay, M into G plus A, and then W will be equal to M. M is 100 and 10 plus 2, and this will be equal to W dash, this will be equal to 100 into 12, and this will be equal to 1200 Newton, and this is equal to 1200 Newton. Okay. 1200 Newton. So this is the apparent weight of man. So this is the apparent weight of man. Apparent weight of man. Apparent weight is greater than actual weight. Actually, in this condition, apparent weight is always greater than the actual weight. Okay, actual weight. Okay, so this is apparent weight is always greater than the actual weight. Okay, guys. So this was the question number 4. This was the question number 4. Now, question number 5. Question number 5. Suppose that a lift is going vertically downwards. Suppose that this is a lift and this man is standing in this, and the lift is going downward with 3 meters per second square, and the value of G is equal to 10 meters per second square. Okay, and the mass of this man M, and M is equals to, okay, mass of this man is M is equals to So, and then m is equals to m equals to yes, m equals to 70 kg. Okay, now calculate the apparent weight. Calculate the apparent weight. Okay, so what will be the apparent weight of this man? Calculate the apparent weight. So what will be the apparent weight? Please tell me. In case the lift is coming vertically downward, in case the lift is coming vertically downwards, then the formula that actually defines the value of actual apparent weight will be w dash, this will be equal to, and this will be equal to m into g dash, and this will be equal to m into g minus a, and w dash, this will be equal to 70 multiplied by 10 minus 3, and w dash, this will be equal to 70 multiplied by 7, and w dash, this is equal to 490 Newton. 490 Newton. Please write down. Please write down. Okay, so this is this is the apparent weight of man inside the lift. And suppose that this is a man. Suppose that this is a man. A man is standing here. Man is standing here. Okay, a man is standing here like this. Okay, and this is pulling. This is pulling a bucket like this. Okay, and this is this, and this is okay. Yes. So this is the bucket. So this is the bucket. Okay, so this is the bucket. Now this man is pulling, and this bucket is going 2 meters per second square with 2 meters per second square with the acceleration. Okay, with the acceleration, and the mass of the bucket is equal to 25 kg. Okay, and the value of g is equal to, and the value of g is equals to and the value of g is equals to 10 meters per second square. 10 meters per second square. Calculate the tension in the string. Calculate the tension in the string. What is the tension in the string? So what is the tension in the string? What is the tension in the string? Question number 6. Yes, guys, when we talk about the tension in the string, then obviously this case is similar to the lift. Okay, suppose that this is a man. Suppose that this is a man instead of the motor, and this lift is just being pulled by the motor with the acceleration like this. So the tension in the string will be similar as the tension. Okay, so the tension will be equal to the apparent weight. Tension in the string will be apparent weight. Okay, tension in the string will be equal to the apparent weight. Okay, so tension in the string will be equal to apparent weight. So apparent weight okay, apparent weight W dash, and this will be equal to T, and W dash this will be equal to M into G plus A, and W dash this will be equal to G. M means 25 into 10 plus 2, 10 plus 2, yes, 10 plus 2. Okay, so W dash will be equal to 25 into 12. So W dash this will be equal to 300 Newton. Okay, so the correct option will be equal to tension. Tension T, and this T is equals to this T is equals to 300 Newton. Okay, 300 Newton. So this is the correct thing. Please note down. Okay. Please write down. Okay, so guys, these are some questions. Okay, and let us move to another question, and this is question number 7. Okay, question number 7 from the chapter Gravitation, and this is, suppose that this is suppose that this is sun. Okay, suppose that this is sun and this is a planet, and suppose that this is a planet. Okay, and the planet is just moving around this, and the radius of this path is suppose that r. Okay, now if the radius of the path is increased to 4 times, if the radius of the path, if the radius of the path of planet becomes 4 times, becomes 4 times, if the radius of the path, if the radius of the path is, if the radius of the path of planet becomes 4 times, then find the time period, then find the time period of planet around sun. Okay, so this is a very good question actually, and this question is based upon the Kepler's second law, or sorry, Kepler's third law, Kepler's third law of planet's motion. Okay, so this is the one of them, and suppose that if the initial radius is equal to r, and the time period, and the initial time period, this is equal to t. Okay, now if suppose that this is under if, okay, if r1 is equal to, okay, if r1 is equal to now r2 is equal to 4r, okay, then t2 will be equal to what? So this is the question actually. Okay, if the path of the planet, of the radius of the path of the planet becomes 4 times, then what will be the time period? What will be the time period? Please tell me. So here we can use the relation, time period is directly, time period is square is directly proportional to the cube. Okay, t square is directly proportional to the r cube. T square is directly proportional to r cube. Okay, so t square is directly proportional to r cube. Now this is t1 square is proportional to r1 cube, and this is first equation, and the t2 square is proportional to 4r1 to the whole cube, and this is the second equation. So we should write it as t2 square upon t1 square, and this is equal to 4r1 to the whole cube, 4r1 to the whole cube, 4r1 to the whole cube. This is r1 cube. Okay, and this is equal to 64 r1 cube upon r1 cube. Okay, so this is r1 cube, and this get cancelled, t2 square upon t1 square, and this is equals to, 64, and this is equal to 8 square, t2 upon t1, and this is equal to 8, and hence t2 is equal to 8 into t1. So the time period becomes 8 times the initial value of the time. Okay, Hmm. Is it clear to all of you? Okay. So, guys, uh, now I will off this session, and tomorrow we will come live at 9 a.m. in the morning, and please join that session also, so that we can discuss some more questions. Okay. So thank you so much, and once again, please do like this session and share this session among all your friends.